Hi everyone, welcome to the vodcast on pH and pOH, acids and bases. Make sure you have your guiding notes and let's begin. So before we begin really getting into the content here, you may already know a lot about acids and bases and pH. So let's see what you remember. What is pH? Well, do you know that there's a scale that runs from 1 to 14 when you're measuring pH? Well, pH, which we'll go over here in just a minute, is a measure of how strong an acid or a base is. So there is a scale that runs from 1 to 14, but do you know what that scale means? So if it's less than 7, we call the substance an acid. And then if it's greater than 7, it's a base. So have you ever wondered where the heck did that scale come from? Or how was it made? In order to answer that question, you're probably going to need a calculator. So let's see if you can solve this first. How many moles are in 1 liter of water? So let's recover some of our background information. I am asking you to solve for the number of moles of water in 1 liter of water. I want you to remember 1 liter is 1,000 milliliters, and each of those milliliters is a gram. So you're going to need to get your calculators out. Why don't you pause the video right here and do a calculation for the number of moles of water. Right, you know that this is just a conversion and that you're going to need to use dimensional analysis. So start with the quantity that they gave you, which is 1 liter. So you're going to need to change the liter to milliliters, or if you just know this, it's already 1,000 milliliters. Then you need to convert the milliliters to mass. Now I want you to remember the density of water means that it's specific to just water. The density of water is 1. What that means is that for every gram, that is also equivalent to 1 milliliter. So really you've got 1,000 grams. Alright, fine. Now that you know that you've got 1,000 grams, let's convert it to moles. Remember, I don't want you to go and use the 22.4 liters is equal to 1 mole because that's for gas. You've got liquid water. So I hope that I've kind of walked you through the steps. And then remember, the molar mass of water is 18. So let's see that dimensional analysis. Okay, if you do your math right, you should get 55.6 moles of water. So why am I doing this? Well, what you may or may not know is that water can actually undergo a very special chemical reaction that looks something like this. The water, naturally on its own without any outside interference, you don't have to stir it, you don't have to heat it or anything, water will ionize. It'll self-ionize. So the self-ionization of water looks like what you see there, the equation. The self-ionization of water is going to create 2 ions. One of the ion is the H plus ion. You guys know that hydrogen has a positive charge because its 1 electron is just lost. And then you also, at the same time that you make the hydrogen ion, you'll also make the hydroxide ion, the OH negative ion. So every time you make an H plus ion, you will also make an OH ion. Why is that relevant? Well, this is the basis of why we created the pH scale. The self-ionization of water does not happen very often. Well, how many moles were in 1 liter of water? 55.6, right? What does this have to do with anything? Well, only 1.0 times 10 to the negative 7 moles of water per liter will dissociate or self-ionize to form hydronium ions and hydroxide ions. Oh my gosh, look at the value of that number. Can you take this number out of scientific notation? Guys, that's 0.0000001 moles out of 55.6 moles of water that will actually self-ionize. Now this number, check out the power here. It is to a power of -7. Now I don't know if you know much about the pH of water. The dissociation reaction that I showed you of water, there is only 1.0 times 10 to the negative 7 moles of water in a liter that will actually self-ionize like this. And remember, the reaction is balanced. Every time you make a hydrogen ion, you will also make a hydroxide ion. So then, some of you are already thinking in the right track. what is the pH of water? Well, it's 7. And we know that a pH of 7 means that the solution is neutral, water is neutral. So then, what exactly is pH? pH is a measurement of the concentration, technically, of the hydrogen ion. By the way, in case you didn't know, another name for the hydrogen ion is the hydronium ion. Okay, so now that's some new vocabulary for you. And that's where we get our pH scale, is by looking at and reflecting on water. So, what is the concentration of the H plus ion in water? Well, in exactly 1 liter, the concentration is 1.0 times 10 to the negative 7 moles per liter. And since it's per liter, that's the concentration, that's the molarity. And then, what's the pH of water? Well, it's 7. Now, I don't know if you know very much about math or I don't know, I think this might be pre-calc maybe, or trig, but there is a really cool math equation that can take you from the molarity of the hydrogen ion to the pH of the solution. Alright, well let's make note of this. If the concentration is a base of 1.0, okay, I want you to look what I mean by a base of 1.0, is this number is a 1.0. If this number in the front, the base number right here, is a 1.0, whatever number is on that power of 10, if you change that negative to a positive, that's going to be the pH of the solution. How easy is that? So remember, the trick only works if the concentration is a base of 1.0. For example, what is the pH of a solution if the concentration of the H plus ion is 1.0 times 10 to the negative 10th molar? Cool, so we do have a base of 1.0. Guys, all you have to do is look right here to the negative power of 10. You're going to change that negative power of 10 to a positive power of 10. Right there. So the pH is 10. And by the way, that means that the solution is basic. So acids produce H plus ions. Bases produce OH ions. And pH is a measure of how much H plus ions there are. Did you know that there's also something else called pOH? Well, pOH would be a measure of how many hydroxide ions there are. And pH and pOH are total complete opposites. So can you think of it this way? If a solution has a pH of 5, what do you think will be the pOH? Now you know the scale for pH runs from 1 to 14. So if something has a pH of 5 and pH and pOH are exact opposites, well, remember, the scale can only go to 14. So what is 14 minus 5? Aha! It's 9. So you see how pH and pOH are exact opposites. That is so easy. So remember, the concentration of H plus is inversely proportional to the concentration of OH. And then also, let's take one last look at this dissociation, okay? So remember that if you dissociate 1.0 times 10 to the negative 7 moles of water, you'll make even quantities of the H plus and the OH minus. So then, the pH of water we already got is 7. Can I ask you what the pOH of water is? Well, it should also be 7. So on the pH scale and on the pOH scale, 7 means neutral. So there's a couple relationships that we need to write down. There's some special formulas that might help you a little bit later on. So one of the most important formulas is the fact that we can take the concentration, by the way these brackets mean concentration, so the concentration in molarity of the H plus ion times the concentration in molarity of the OH ion will always equal 1.0 times 10 to the negative 14. Right? If you try this for water, it totally works. 1.0 times 10 to the negative 7th times 1.0 times 10 to the negative 7th is going to be 1.0 times 10 to the negative 14. And remember, since the scale runs from 1 to 14, you need to also remember that pH plus pOH will always equal 14. So if the pH is really high, that means the pH is going to be low and it's a base. And if the pH is really low, then that means that pOH is going to be very high and it's an acid. So now you got to learn how to formulate in both directions. You got to be able to think forward, you got to be able to think backwards. So a low pOH would be a base, and a high pOH would mean it's an acid. So it's exact opposite of pH. Now that you, now what if you don't have a base of 1.0 for the concentration? See, I've been talking about the math so far. It was really, really easy. And I kind of gave you a very generic way of thinking about pOH. But now let's try something a little bit more complicated. And we're going to get into some serious math here. So now I want you to try something totally different. What is the pH of a solution with an H plus ion concentration of 8.45 times 10 to the negative 4? So mental note here, this number right here is not 1.0. So if you thought that the pH, since we're talking about hydrogen ion concentration, if you thought the pH is 4, well, you're close, but because you don't have a base of 1.0, you'd be wrong. So now you need to learn how to use your calculator, folks. Okay, so on your calculator, we are going to do this formula here. I don't know if many of you understand the math behind how you went from a power of 10 to just a whole number, but that is exactly how you do logs. So pH is equal to the negative. You know how like on the power of 10 on the molarity you've got negative numbers and then it magically turns into a positive pH? Alright, well that's why we have this negative sign right here in the front of the formula. So this is very easy for students to forget, so make sure you get this correct on your guided notes. Make sure you got that negative sign. So pH is the negative log of the concentration in H, and this concentration has to be in molarity. Alright, so moles per liter. Alright, so let's type this into our calculator. You're going to first type in the negative sign. Make sure it's not the minus sign. Alright, I think you guys know what that is now. Then hit your log button. On some calculators it's going to look a little different. When you hit the log button, some calculators will automatically open a set of parentheses. That's totally fine. And if not, you know, it's no big deal. Oops, big deal, typo. Now you need to punch in the concentration of the solution that I just gave you in the problem. That was 8.45 times 10 to the negative fourth, and that was a molarity, and that was a concentration of your H plus ion. Alright, so get that in there. Then if the parentheses were opened for you, you're going to close them and just press enter. Now, in word of caution, some calculators demand that you punch in the number first and the function second. So on those particular calculators, when you go negative and then you hit log, you might immediately see a error, and it'll say syntax error. All right, what your calculator wants from you is for you to punch the number in first. So if that's the case, you're going to hit the negative sign, punch in this number, and then simply hit log. And when you do that, you'll get your answer. All right, so what should you get? You better get 3.073, and then make sure you have that right answer. If you cannot get the right answer, you need to ask for help, and I'll come around and I'll help you right now. Just pause the video. Now, can you remember a couple ways to calculate from here? You can calculate pOH. Now that you got your pH is 3.073, you can go from pH to pOH, and that's exactly what I want you to do at this point. So practice right now. Go, now that you have pH, go to pOH. You should get 10.927. Now you can actually go from pOH to concentration OH. But this requires you to use something called the anti-log. And I handed you a diagram when you walked in. I want you to look right now on your calculator. You should be able to see an anti-log button on your calculator. And the anti-log button is right above your log, and it should say 10 to the x. Check for that. Find that button. If you can't find it, you make sure you ask. It should be resting right above your log button. And to access any buttons sitting above, you're going to have to use your second key or your shift button. You should have something like that. If you have any questions on how to access your anti-log, please, again, raise your hand. So what we're going to do right now is go from your pOH, all right, to the concentration of your OH ion. So the formula kind of looks like this. So concentration OH, all right, remember this is molarity, concentration of your OH ion, would be equal to the 10 to the negative pOH. Alright, so you would literally, on your calculator, let's do it together, find your anti-log button first, hit that anti-log button, make sure you put in your negative sign, and then type in 10.927. And your answer will be the concentration of your OH ion. You should get, for your final answer, 1.18, oops, sorry, struggling here, 1.18 times 10 to the negative 11. Now I want you to notice something kind of cool. All right, you see this value, 10.927. Did you notice that 10.927 is really close to this negative value right here? And that's kind of how these logs and anti-logs work. So just remember that the value here that you just solved for is a concentration. All right, you see the brackets, and concentration is molarity. All right, so that was the concentration of your OH ion based off of this value right here. All right, so we've come full circle. What we now have established is a formula for pH, a formula for pOH, and we also have discovered how to go from pH or pOH to concentration. All right, it's the anti-log. So you've learned how to do the log button, you've learned how to do the anti-log button, and so that takes you forward and backward. Okay, so just one final recap. We've established that hydrogen ion concentration times hydroxide will give you 1.0 times 10 to the negative 14. We also discovered that the hydroxide ion concentration is equal to the anti-log of the pH, and then it's also reversed for the OH. And then the pH scale runs 1 to 14. Let's see, pH and pOH are exact opposites. And then don't forget that whenever you have a concentration with a base of 1.0, those problems are super duper easy. So I hope this helps you, and follow the little diagram that I put onto your guided notes, and you should be totally set. Eventually you will memorize that diagram, but for now, on your tests, on your quiz, you will be able to use that diagram. Okay, I hope this helps, and if you have any questions, make sure you ask so that you know how to use your calculator. Alright guys, that's all for now. Take care.